In this video, we'll be talking about the other main type of power index in weighted voting. This is called the Shapley-Shubik power index, and it's different from the Banzhaf power index because it deals with sequential coalitions as opposed to just normal coalitions. So a normal coalition was what? So a coalition was just a group of players, and either it could be a winning coalition or a non-winning coalition. So sequential coalitions are going to be coalitions where one thing that has to be met is that these coalitions include all of the players in the game or the weighted voting system. So if there's 3 players, let's say there's P1, P2, and P3, then all sequential coalitions are of size 3. They include everybody. But as the name suggests, sequential coalitions, they have to do with sequence. So even if you have this normal coalition, this represents 6 different sequential coalitions, and they're made by just shifting around the order of these players. So in these coalitions, the sequence or order of the players matters. So this is the main difference. When we were talking about the Banzhaf power index, the order of the players didn't matter. For example, if I wrote this this Banzhaf coalition right here, P1, P2, and P3, it would be the exact same thing as if I wrote something like P3, P1, P2. No difference, right? It's just these same players. But in sequential coalitions, these are 2 very different things. And to distinguish between when we're using regular coalitions with the Banzhaf method and sequential coalitions with the Shapley-Shubik method, we'll be doing these arrow brackets instead of these curly brackets. So again, with 3 players, we have 6 different sequential coalitions. How many do we have with 4 players or 5 players? Well, it's pretty simple to do if we just do a little bit of math. So the first place, how many choices do you have for that person? Well, let's say there's 4 people, for example. You have 4 choices for the first place. Now the second place, how many choices do you have? Well, one person's been taken by the first spot, so you have 3 choices. Now the next spot, how many choices would you have? You would have 2. And the last spot, it would force the remaining person. So 4 times 3 times 2 times 1 is equal to 24. So with a 4-player system, you would have 24 different sequential coalitions, which is what we see down here, what I've written down here. So this monster, we'll get to it in a second. But with 3 players, it's simple. There's just 6 of them. So now what I've written here, note, all sequential coalitions they are all winning. There's no such thing as a non-winning sequential coalition, because if you include all of the players, then the quota should be met, right? If it's a good weighted voting system, then it should be enough to get the quota to be met. So all sequential coalitions are winning, so there's no such thing as a winning sequential coalition. By saying sequential coalition, you're implying that it's winning. Okay, so now let's talk about the other concept. We had something called a critical player with the Banzhaf method, and that was a player that if you took them out and it was a winning coalition, then it would be a non-winning coalition. A pivotal player is a little bit similar. So it's somebody that, let's look at this first one. So this is a sequential coalition. It's just the simplest one. It's P1, P2, P3, and P4 in that order. Now, in the sequential coalition, the pivotal player is the person who changes it from a loss to a win. So let's see what that means. So for example, in this case, we have P1. And what's the weight of P1? Here's the weighting system. It's quota 12. P1 has weight 8, P2 has weight 4, P3 2, and P4 also 2. So in this one, if we just have P1, how much is that? That's 8. That's not enough to get to 12. Now if we add P2, how much is that? That's going to be 4 more. That gets us up to 12, which is enough to meet the quota. And because P2 is the person that caused that, we call him the pivotal player in this case. Now let's go down to, let's say, this one right here, the third one. So we have P1, P3, P2, and P4. If we have P1, how much do we have? We have 8. If we add P3, we have how much more? 2. So now we're at 10. Is that enough to meet the 12? Not yet. Now if we add P2, we're at what? We're at 10 and 4 is 14, which is over 12. Therefore, P2 is the pivotal player in this case. And that's just how we do it. So I've listed all 24. Remember, we said that there are 24 for 4 players. I've listed all 24 sequential coalitions, and I've underlined in blue, in each case, the pivotal player. So now what we do is pretty much similar, same thing as Banzhaf method. We count how many times we've underlined this, so we count how many times players are pivotal. So I found that P1 I've underlined 14 times, P2 I underlined 6, P3 and P4 I each underlined twice. And this is consistent with power rules because we see that P3 and P4 have the same weight, so they should have the same power in the end, which makes sense. They have the same number of underlines. So now that comes out to a total of 24. So now I just do the same thing as when I did Banzhaf. I take 14 divided by 24, which is a total, and I get 58 and 1/3%. I take 6 over 24, I get even 25%. And when I take 2 over 24, I get 8 and 1/3% each. So we're now ready to fill in half of this table. So P1, SSPI stands for Shapley-Shubik power index. So for player 1, it was 58 and 1/3%. For player 2, it was 25%. And for players 3 and 4, it was 8 and 1/3% each. Now the last thing I want to talk about is how this relates to the Banzhaf method. So I've put on this little slip right here. I have the same weighted voting system. It's 12, 8, 4, 2, 2. That's the same thing I had on the other paper. Now I'm going to apply the Banzhaf method. So first thing we know is this is a little bit easier to use because instead of writing out 24 different things, I've only had to write down about 5. So let's look at what's the size 2 winning coalitions. So the only one of size 2 is if we have players 1 and 2. So that's these two. And who's critical in this case? It's going to be both, because if we take out either one, this becomes a losing coalition. Now what's the size 3? There's 3 size 3 ones. There's P1, P2, P3, P1, P2, P4, P1, P3, P4. And notice that since these are using the Banzhaf method, I don't have to write down all the different permutations of this. I just have to write down combinations in a sense. So now who's critical in the first one? P1, P2. Who's critical in the second one? P1, P2. Who's critical in the third one? Everyone. And the only size 4 winning coalition is going to be everybody, of course. So who's critical in this case? Only P1, because if we take out anybody else, it'll still be a winning coalition. So now this is a little bit easier to calculate. P1 is critical 5 times, P2 3 times, P3 and P4 critical 1 time each, for a total of 10. And so if we want to calculate P1's Banzhaf power index, that's going to be 5 over 10, or 50%. And 3 over 10 is 30%, and 1 over 10 is 10% each. So now we're going to write that into the table for BPI, which stands for Banzhaf power index. So we had 50%, we had 30%, and we had 10% each. So notice something. Let's notice 2 things. The first thing we should notice is, of course, these numbers are different, which means the Shapley-Shubik power index and the Banzhaf power index are not always going to be the same. Often they'll be different. There'll be different numbers you see here, and sometimes they'll be radically different. But the second thing that we can talk about is that usually, such as in this case, they're not radically different. They're not like that crazy off of each other. For example, 50 and 58 and a third percent are only 8 and a third percent off. These are 5% off, and these are even less than that. So they're not usually going to be that far off. So both of these power index are they have their shortcomings, their strengths. For example, just right off the bat, you might see that pivotal player, it requires you to write out all 24 of these and underline every single one, which could be tedious. Whereas with the Banzhaf one, I only had to write down about 5 things because I don't have to do permutations. I just have to do combinations here. But if you have a computer that's going to do this for you, if you program it, then it really doesn't matter which one you do if you have a relatively small amount of players. So go ahead and look at both, do problems involving both, see if you get different results, and hopefully this helps you kind of understand the mathematics of power a little bit more.